Okay, question number 9 from P2 practice paper A. Part 1 says calculate F2. So F2 is going to be when you substitute instead of x 2. So you'll have minus 3 times 2 cubed plus 8 times 2 squared minus 9 times 2 plus 10. That's going to give me minus 3 times 8, which is negative 24, and 8 times 4, which is positive 32, and minus 9 times 2, which is negative 18, and plus 10. So here we're going to have, let's have a look at this. You're going to have 32 minus 24, that's going to be 8, and minus 18 plus 8, which is minus 8, which is equal to 0. So we can say that F2 is equal to 0. Should really write it down here. This says write f of x as a product of two algebraic factors. Well, as f2 is equal to 0, therefore x minus 2 is a factor. Is a factor of fx. Okay, that's from the factor theorem. Okay, any number you substitute into there, then x minus that number is going to be a factor. Okay. Now, so we can say that x minus 2 multiplied by something is going to give me minus 3x cubed plus 8x squared minus 9x plus 10. So we want to find what this is. Now there's different ways of doing it. One of them is algebraic long division, and it doesn't tell us to use that method, so it's up to you. Sometimes they do insist on it, but we know that there's going to be a quadratic times a linear was going to give us a cubic. So this is going to be ax squared plus bx plus c. Now a nice way of doing this is by what's called recognition. So we compare, for example, the x cubed terms on both sides here. So this is x times ax squared is going to give me the x cubed term. So on this side you're going to have a as your x cubed term. On that side you got negative 3. So we know a must be negative 3. That's the only way you're going to get negative 3x cubed. Okay, and the next thing that's easy to look at is the constants. Okay, constants, because there's only one way of getting a constant on this side is minus 2 times c. So you can say minus 2c is a constant on this side, and there's only one constant on that side, which is 10. So we can say therefore c is going to be 10 divided by 2, which is minus 5. So we now know that this is minus 3 and this is minus 5. Now we're left to find b. So what we can do is, to find b, we can compare either the x's or the x squareds. It doesn't really matter too much, because it's a similar kind of process getting both of them. So let's look at the x. Let's look at the x terms. Let's look at the x terms. How am I going to get x term when I multiply here? Well, x times that will give me x cubed. X times that will give me x squared. X times c is going to give me the x term. So you're going to have c. But there's also, when I do minus 2 times b, I'll also get an x term, won't I? So minus 2 times this is going to give me a x squared term. Minus 2 times bx is going to give me a x term. So minus 2b. Okay, and minus 2 times that give me got a constant. So yeah, so this combination of these two is going to give me my x term, which is minus 9. I could have used x squared if I wanted to, in which case it would be minus 2a plus b equals 8. Okay, and because I already know what c is, I can say minus 5 minus 2b is equal to minus 9. So minus 5 plus 9, which is going to be 4, is equal to 2b. So b is equal to 2. Okay, so now we have found all the missing parts. So we can say that f of x can be written as x minus 2 times minus 3x squared, okay, plus 2x minus 5. Okay, so that's part 2 done by a method which is called comparing coefficients. Okay, I'm also going to show you how to use the other method, which is algebraic long division. Okay, and that is as follows. We know that x minus 2 is one factor. Okay, so if I set it up as x minus 2, and you're going to divide by x minus 2 minus 3x cubed plus 8x squared minus 9x and plus 10. Okay, that's what you're going to divide. Let me make that a bit neater. I'll just cheat. Okay, now if I divide this by that, and I know x minus 2 for sure is a factor, I will get a remainder of 0, and what will be left with up here is the factor, which should turn out to be the same as this. So I'm just going to show you another method. Okay, some people prefer this method where you compare the coefficients. Some people prefer this method where you do long division, algebraic long division. So x into minus 3x squared goes x into minus 3x cubed goes minus 3x squared times. So you can see that, that's where that comes from. And then, okay, so now minus 3x squared times x is minus 3x cubed. And minus 3x squared times minus 2 is plus 6x squared. So now I'm going to subtract this line and that line. So this gives you minus 3x cubed plus 3x squared. That always will cancel out. 8x squared minus 6x squared is 2x squared. And I'm going to bring down the next term, which is minus 9x. Okay, but I forgot to mention, before you start, if there's any of these terms missing, you have to put 0 of that term. For example, if there was no x squared term, I can't write minus 3x cubed and then minus 9x. It will make everything out of place. So I have to, if there was no x squared term, for example, I'd have to put plus 0x squared, then everything will be in the right place. Anyway, we didn't have to worry about it in this particular question. Okay, so now, x times something gives me 2x squared. I have to write it up there. Well, x times 2x gives me 2x squared. Then I do 2x times this. 2x times x is 2x squared. And 2x times minus 2 is minus 4x. Again, be careful about your subtraction. This becomes 0. Minus 9 minus minus 4 is minus 5. Okay, so you got minus 5x. Okay, because it's minus 9x plus 4x. Bring down the 10. And we notice so far, you got minus 3x squared plus 2x, minus 3x squared plus 2x, same thing. Now, x times minus 5 gives me minus 5x. You see, that's exactly the same now. So just minus 5 times x gives me minus 5x, and it should end up being the same. Minus 5 times minus 2 is plus 10. You're left with no remainder. Because there's no remainder, that means that must be a factor of this, and this is another factor. So we can therefore say f of x is equal to x minus 2 times negative 3x squared plus 2x minus 5. So there's two different methods. You don't have to use both of them, of course. There's one method, comparing coefficients, another method, algebraic long division. Whichever one you feel comfortable in using, you can use. Okay, there's also other methods as well, and these are the two common methods. Now, it says use the answer to A part 2, prove that there are exactly 2 real solutions to the equation given. Okay, so let's take the answer to A part 2. I have it written down. Where is it neater? I think it's neater here. So take this answer, copy, and paste it over here. Okay, where was it gone? There we are. Okay. Now, using the answer to A part 2, prove that there are exactly 2 real solutions to this. Okay, so basically, we can see, if we look at the original equation, which is here, nope, I thought I'd put it here somewhere, but I haven't. So let me take it. This is the original equation. Okay, I need to know what f of x is to compare it. Okay, so this is our original f of x, and this is what it became when we wrote it as a product of two factors. Now, we know that you can see here, if you compare these two, that the x has been replaced by y squared. So we can say that minus 3y to the power of 6 plus 8y to the power of 4 minus 9y squared plus 10 equals 0 can be written as basically this, okay, has been y. Yeah, so if you were to solve this equation, okay, if you were to solve this equation, you want to show that there are exactly two real solutions to the equation. So basically x equals 2 would be one solution, okay, to this equation. Let me just get rid of that. Sorry, I'm just waffling there, sorry. Now, I know if I solve this equation, x minus 2 and minus 3x squared plus 2x minus 5 equals 0, I'll have x equals 2 as one solution, and minus 3x squared plus 2x minus 5 equals 0. Now, does that have a solution? Let's find out. Okay, if that has a solution, okay, then b squared minus 4ac will give us a value which is either 0 or positive. If it doesn't have a solution, then b squared minus 4ac will give us a negative value. So let's find out what b squared minus 4ac gives us. So b is the coefficient of x, so that's 4 minus 4 times a, which is minus 3 times minus 5. So it looks like we're going to get no solution, because you're going to have 4, and that's going to be minus, well, that's 20 minus 60, so that's going to be negative 64. So therefore, okay, b squared minus 4ac is less than 0. So this part, so minus 3x squared plus 2x minus 5 equals 0, there's no solution. So there's only one solution, which is x equals 2. So how do I use that to prove that this has only this has two solutions? Okay, because I know x is equal to y squared. Okay, so we know x is equal to y squared, so y squared is equal to 2. Therefore y is equal to plus or minus the square root of 2. Okay, so therefore we can show that there are two solutions. Okay, therefore two real solutions to the equation that we're given. Okay, oops. There we have the answer to part B. Okay, so now part C, deduce the number of real solutions for theta between 7 pi and 10 pi to the equation 3 tan cubed theta minus 8 tan squared theta plus 9 tan theta minus 10 equals 0. Okay, so now we can see here that this looks almost the same as this. Okay, and you got minus 3x cubed plus 8x squared minus 9x plus 10. If I make that equal to 0 and I multiply everything by minus 1, I'll get 3x squared minus 8x, 3x cubed minus 8x squared plus 9x minus 10 equals 0. And now you can see that these are exactly the same in terms of the coefficients and the powers. So in this case we can say x is like tan theta. Alright, and whether I have it in this way or I have it in this way, I'll still get the same solutions. They'll still equal 0 at the same places. So there's only one solution, was when x equals 2. Okay, that was the only solution. All the other factors didn't give any solutions. So that means the only solution to this is when tan theta is equal to 2, because x is tan theta. So let's see how many angles we can get in that range between 7 pi and 10 pi. So we're going to use radians. So I'm going to take my calculator. I'm going to make sure it's in radian mode, which it isn't. So I'll shift mode 4. And then I'm going to press inverse tan of 2. And I'll get 1.1071. I'll just, whoops, where did it go? What am I doing? Inverse tan 2. Okay, so I'm going to store it as A. Okay, so that's 1.1071. Okay, 1.1071. Now that is not in the right range. We want the range between 7 pi and 10 pi. Now I'm going to write down what those are in terms of decimals, okay, because I don't have this in terms of pi. Alright, so let's write down what 7 pi is in terms of decimals. I have to just do 7 times pi. Okay, 7 times pi gives me, as a decimal, 21.99. So that's 21.99. And 10 pi is going to be 3.14, so it will be 31.42. 3.142 multiplied by 10. Okay, so now what I have to do is, okay, let's look at it from this perspective. In fact, this is a bit cumbersome. There's an easy way of doing it. Tan theta is positive. Tan theta is positive in these two quadrants. Okay, so if this is 0 and this is pi, then you're going to get 2 pi here and you're going to get 3 pi here. So you'll end up with 7 pi here. Okay, so when you go through, you get 7 pi to 10 pi. So 7 pi, it's going to hit it once. Then you're going to go 8 pi. Okay, you'll hit it twice. Okay, then you're going to go 9 pi. Okay, it's going to hit it 3 times. You got 1, 2, 3, and then 10 pi, it will stop there. So you can see there's going to be 3 solutions. So therefore, 3 solutions. Okay, that's an easy way of doing it instead of going through all this. I didn't need to go. That's a lot of hassle. Just think about the curve or think about the unit circle. Tan is positive in these two quadrants. A, S, T, C. Awful STC. Okay, so here we have tan is positive in these two quadrants. You're going to have the odd pi's here and the even pi's here. So you're going to get to from 7 pi to 10 pi. Okay, so you're starting, once you've gone to 7 pi, it's going to hit it once before you get to 8 pi. Another time before you get to 9 pi. Another time before you get to 10 pi. So that's once, twice, thrice, and then you've stopped. Okay, so there's 3 solutions. And that's the answer to this question.